this paper may not have any trick. Here we go, some trick. All right, so we've got a type of a question here from June 2014 paper. Can we work with this one?
Yes, sir, we can work with this one.
So what I will do is I will just need to take that question and place this on a new page. Where are you, Rohit?
Yes, I am here.
At home?
Yeah, at home.
Okay. So we've got solve for 0 to 360 degrees, and we've got a formula 9 sine equals 4. Now it's a sine curve, and the thing about sine curves is they normally start at 0, finish at 360 degrees. They did not ask us to draw a graph, did they?
No, sir. They just showed.
But if we were to draw a graph, it would go up to 9 and down to negative 9 because it's 9 times sine. And here, plus 60, which means there's a translation of 60 degrees to the left. So it's going to be slightly out of sync by 60 degrees translated this way because it's plus. What we're after in this question is, where does it equal 4? Now, I'm going to put a line across here at about 4, a bit higher than 4. You can see it's going to intercept that curve at 2 places. And we're after, where is it, where does it cross that graph from 0, only from 0 and on. We don't worry about anything in the negative. Well, it might cross very soon. If I've drawn it correctly, it might cross very small number, or it might cross over here. So let's have a look at the formula. The objective is to just get the sine on its own. So what we will do is we'll take that just times 9 across to b, divide 9. Treat this like an angle. Now this angle here, sine of that angle equals 4 over 9. Therefore that angle, which is a bracket, is going to equal the inverse sine of 4 over 9.
All right.
To find the angle, we pick up our calculator with shift sign. Make sure your calculator is set to degrees. Make sure your calculator is set to degrees.
Yeah.
Yeah. We've got
so 26.38.
Good. So we've got 26.38 here. Now this is what theta plus 60 degrees equals. Now, keep in mind we have to subtract, and we can't go into the negative. 26.38. 7, okay, 9. Where else will it, what's the next angle above 26? Because if I subtract 60, I'm going to get a negative. So what's the next biggest angle? Now sine is positive in the first quadrant and the second quadrant.
Yeah.
So whilst we've got 26.387 in the first quadrant, 26.387, we could also say in the second quadrant, it would be 180 minus 26.387 equals, what's that angle?
Minus 153.61.
Good.
Yeah.
That's going to be the angle that works for us.
All right.
It didn't work, and I can tell by the graph, it's either just going to be, its first angle is going to be just negative, and we might have to go to the next. And to find the actual answer we want, we have to subtract 60 degrees. So we've got, then we want one decimal place.
So 93.6. All right.
So we've got question 7, part 1, 4 marks. You must show each step of your working. So even over here, the working I did, I should not put that on rough paper. I should put that in with my working to say there are 2 angles that sine of theta would be 4/9. Yes, sir. Right. Now we've got a little bit more difficult question coming up. 2 tan x minus 3 sine x equals 0. Now giving your answer 2 decimal places where appropriate. Should solutions based entirely on graphical or numerical methods are not acceptable? So does that mean they want a combination of both? So solutions based on entirely on graphical or numerical. So do they want a bit of graphical and a bit of numerical? Oh.
All right.
So,
half of each, yeah, got it.
So let's have a look at this equation. 2 tan x. Now tan x, we've got tan doesn't have any values for pi on 2 and negative pi on 2. Knowing your graph for tan x. And we've got to go to negative pi and positive pi. And just drawing this graph here, that's the graph of tan x. 2 tan x would be stretched, so it looks still similar. So we've done this.
Okay.
Now we've got to take that graph and subtract this graph. That will 3 sine x looks like this. There's 3. And that's 2 pi, but we don't want 2 pi. And that's at 3. And that's that.
Minus 3.
And we've got to go back to pi, don't we? So we've got to come down like this. All right. There's going to be a few places where the graph minus the graph is equal to 0. That means the height, this height, and this height are the same. So it means here is one place we're looking at a perspective. That's a possible answer. There's a possible answer. There's a possible answer. There's a possible answer. And we can include that number because it's right. And we can't go any further than pi. Oh, do we include that value? Pi.
No, sir, we don't, because it's just less than.
It's a less than. So we do not include that solution. So we're looking for an answer with 3 solutions. So we're expecting to get x equals 1, 2, or 3. Let's look at the numerical methods now. 2 sine x over cos x. See what I'm doing here? Minus 3 sine x equals 0. See what I've done? Yeah? Now, I'm not sure if this is going to work. I'm going to take this across to the other side. 2 sine x cos x. I'm going to take that across to 3 sine x. Well, see what's going to happen here to sine x? It will cancel. Minus.
Sorry, sir?
See how I've got a sine x on both sides? See how I could cancel if I wanted to? Can you see that?
Yes, sir, you can...
See, I could cancel that?
Yes, sir.
Don't ever cancel. If you cancel with an x, you will cancel one of the solutions. So what I'm going to do is I'm going to bring that back. I don't want to cancel it, all right?
Okay, don't cancel it.
I'm going to factorize this. So sine x can factorize. That's 2 over cos x minus 1 equals 0. Now we're cooking with gas because now I can say sine x equals 0 because I factorized. Or this bracket can equal 0. You see that?
Yes, sir.
Or 2
And
over
x
cos
equals
x
0.
equals 1. I'm going to say, well, actually, I won't cut some into it. Minus 1 equals 0. Therefore, 2 over cos x equals 1. Therefore, I can put the cos up there and put the 1 down here. Something's wrong.
Cos x is equal to 2.
Can't have a cos x equals to 2. Can't have a cos minus 3 sin x. That's not possible. Can't have a cos minus 2 sin 2 cos x. Hang on a minute. What are we doing on? Thank you. Jonas just spotted it. I've made an error here. Back row wrong. See that? I'll just fix that. Now we're right. We've found our mistake. Thanks, Jonas. Good to have you on board. Therefore, cos x will equal, and you can now see cos x will equal 2 on 3. Yeah?
Yeah.
All right. Where is cos positive? Cos x is a positive number. In what quadrant?
The fourth quadrant and the first quadrant.
Fourth quadrant and the fourth quadrant. Notice we're allowed to go back to negative pi. So we're actually allowed to go all the way, anything from 0 to negative pi and 0 to positive pi. So we're going to have a first quadrant angle and a fourth quadrant angle back.
Okay.
So theta and negative theta will give us a positive 2/3. So what is the inverse cos of 2/3? Inverse cos of 2/3. What is our angle?
48.19.
Okay, can we convert now? Have a look at our question. Can we put radians in our calculator? Because this is pi, and we don't want degrees, we want radians. So inverse cos of 2/3 with radians factor.
0.84.
Two decimal places. 0. What's the next number that we have? 8410. Okay, good. All right, can you tell me what our answers are then, our three solutions? X could equal?
X could equal 0.84.
X equals the first quadrant, 0.84.
Yeah.
Yeah.
Then 2 pi minus 0.84.
Okay, you've gone up 2 pi, you've gone up higher than pi, haven't you?
Sorry.
Yeah. Look, you do that. What is 2 pi minus 0.84? What is 2 pi minus 0.84?
5.44.
Okay, now subtract 2 pi to take it back one revolution. Minus 2 pi.
Minus 2 pi.
Yeah. You see there are two different types of angles in the fourth quadrant. There's simply negative theta, or there's 2 pi minus theta. And we want the negative theta because that's within our range of negative pi to positive pi. You see, the other angle was correct, but it was too big for our allowable range. So by subtracting 2 pi, what does it bring it back? Negative 0.84.
84.
And one more solution. Sine of x equals 0.
0.
And there is our three. You've got the graph. You've got this value 0. You've got that value here of 0.84. And you've got that value of negative 0.84. And you can see the picture of where the graphs are at the same place. And that's all we've got time for today. Sorry about the delay during room changes. Thank you, Rohit, for coming online. Thank you, Joanna, for showing up personally. This is recorded, and you can have a look at the YouTube, and we will put that link on Edmodo.
Okay, sir. Sure.
I hope today has been helpful. And if you have specific questions, just put it on Edmodo, and I will do a similar session, whether you're attending or not, and you will be able to